Okay, so the derivative of logarithms with any base is similar to what we just did with the other one with the exponentials with any base. It's a little bit of a rewrite first before we take the derivatives. So I can rewrite y is equal to the natural log of x over the natural log of 2 using the change of base. Or, like I've said before, some people like writing it as 1 over the natural log of 2 times the natural log of x, because this right here is just a constant. It's just some decimal you can find on your calculator. So we're going to take y prime is equal to, like if I had y is equal to 3 times the natural log of x, it would be 3 and then times 1 over x, because that's some constant multiplier. If I had 3.973 times the natural log of x is equal to y, and I'm taking the derivative, I would be 3.973 times the derivative, which is 1 over x, which is y prime. So just because it just looks like differently, it's 1 over the natural log of 2 is some constant. So when I take the derivative of that, it becomes 1 over the natural log of 2 times 1 over x. And if I just neaten that up a little bit, it becomes 1 over x times the natural log of 2. Now I want you to try the second and also make a conjecture for the general function here. Pause it and try. That's what I'm getting for the second one. You hopefully have a little more work than I do. And then the general would be, if I take the general function y is equal to log base a of x, it would be 1 over x times the natural log of a. And that's where we are at here. Just a few things. A has to be greater than a 0, and a can't equal 1, or else we can't take a logarithm of it. The base, we have some rules for the base there. And we ended up with 1 over x to the natural log of a. And we can also apply the chain rule to that. So same over here, times du dx. Some people like writing it like this instead. U prime over u natural log of a. Whichever way they like. Either way. All right, so let's try some problems. So in this particular case, I know the logarithmic rule, f prime of x, is going to be, it's 1 over 2x. However, the base is 5, so I have to also divide by the natural log of 5. And then I have to use the chain rule, so times 2, because the derivative of the interior. So that's going to give me 2 over 2x natural log of 5. The 2's cancel out. I get 1 over x times the natural log of 5. I'm just going to go down. You're going to try in a minute B and D on your own. I did, if you have an older version of the notes, I had a typo on there. So if you guys could, I may have fixed it in your notes. I don't remember. But you may have to fix it. So if you could do that, it needs to be minus 5x squared is equal to y. I don't know. It didn't make any sense. It had an equal sign. So if you could change that, that would be great. For part C, the outermost function is the power. So I still have to use and then use the chain rule for, so the inner function is, I have to use the chain rule. So the outer function tells me, okay, I just got to use the power rule first, log base 4 of x to the 4th, times, and now I can take the derivative of the interior, which is 1 over x times the natural log of 4, and then the derivative of x is just 1, so then we're done there. And then I can just leave it like that. Okay, pause the video and try B and D right now. Here are the answers. Like if for question D, by the way, you could have, if it's just asking for the derivative, you can leave it, but I just worked on the preferred form of making it a single term. Are you required to do that? Not necessarily. I just did a little bit of simplification for that. Okay, so a few mixed differentials here with different bases, logs, and a little bit of chain rule and things like that. So if you could please work, I'm going to do A maybe with you, and then C, and then you try B and D on your own. So if I'm taking the derivative, oh, we have an exponential, which is itself 4x times the natural log of the base, natural log of 4, times the derivative of the exponent, which is 1. So I don't really need to write the 1. And then it's minus 1 over x, but because the base is not e, it's going to be times the natural log of 2. Okay, done. Going straight down. In this case, I have to do a little bit of chain rule here. It's going to be 1 over tangent of x. That's what's inside the logarithm. The base is not e, so that's the natural log of 10, times the derivative of the inner function, which is secant squared x. So that's going to be secant squared x over tangent of x times the natural log of 10. And I will bet you anything that most often you will be asked to simplify that if that's possible. And I know that it's a little bit, if you have secant, if you look at secant squared of x over tangent of x, just that part of it, secant, remember, is 1 over cosine squared x. And tangent is sine of x over cosine of x. So that's going to give me 1 over cosine squared x times cosine of x over sine x. So a set of the cosines cancel out. So then I could rewrite this as here, secant x over sine x, natural log of 10. That's one option. Another option could be this. Could be this. I'm not saying it has to be, but it could be 1 over, and then I have sine of x cosine of x, natural log of 10. And if I multiplied the numerator and the denominator by 2, this here is the double angle for sine. So you could rewrite this as 2 over sine of 2x natural log of 10. The only reason I'm making you aware of that is if it was a multiple choice question and you weren't seeing the answer, you may have to simplify some of the trig. Okay, let me just show you, pause it and do B and D. Okay.